Hi everyone, I'm Wenxuan Zhang. I'm currently a PhD student in the Chinese University of Hong Kong. Today I actually share our paper answering product-related questions with heterogeneous information. So firstly, I'd like to briefly introduce the background of this work, which is the PCQA platforms. So nowadays, people are very used to shopping online. Similar with shopping in real life, a user often has some questions regarding his or her interested product. To help those potential customers to settle their concerns and stimulate their purchase decisions, product-specific community question answering platforms have been provided on many e-commerce websites to help them communicate with each other to obtain some useful product information. So here gives two example. The left one is from Amazon. The right hand one is from Taobao. So as we can see, a user can post some questions, and other users can freely answer them depending on their willingness. However, as we can say, answering those questions totally depend on the willingness of those formal buyers. And very often it takes a long time for an asker to get an answer, which will definitely affect the user satisfaction since they typically want to have some instant responses. So this motivates us to investigate the task of automatic PQA, which is to provide instant answers for product-related questions in the e-commerce scenario. So many research efforts have been done in this direction. Some early work consider answering yes/no type questions, while they try to classify the answer type by identifying the opinions from relevant reviews. And one important line of work is the retrieval-based method. Well, the main idea is to retrieve some relevant information, product information, which is often the review set for a given question. And some other work also use relevant QA pairs from existing QA collection to answer the given question. But we can imagine that not all newly given questions can be found some relevant questions in the existing QA set, making such a setting less practical in the real-world situation. And another important line of related work is the generation-based method. This is motivated by the recent advance of text generation techniques. So they aim to generate a natural sounding answer sentence from the product information. And more recently, some work also try to leverage the user opinion information during the generation process to generate more opinionated answers for a given question. However, there remain some limitations of this existing work. Firstly, a larger kind of information, namely product details, provided by the manufacturer, are usually ignored when retrieving relevant product information. So, as shown in the example here, we can see the product details cover various information about this product. For example, some bullet point and the product specification table. So we can see that such information can be essential for questions looking for factual type information due to their reliability and preciseness. So secondly, it requires a large number of labeled question review pairs, whose annotation is a time-consuming and laborious work. So to tackle those limitations in this work, we aim to, given a product-related questions, we exploit both the corresponding product details and user reviews to return a rank snippet list serving as the response. Secondly, we want to design a more effective method to tackle the shortage of label data for training such models. But to utilize the information in both information sources, there are some new research challenges. Firstly, we can see that the product details include both natural language sentence and the attribute value pairs. And also in the user reviews, they are all natural language sentences. So the heterogeneity of those candidate information needs to be appropriately handled. Secondly, product details and user reviews contain different types of information, which are suitable for answering questions with different information needs. So as we have discussed that if a user asks a factual type question, then the information from the product details will be more reliable. Thirdly, training a model to capture the relevance between the question and the candidate snippet with the typical supervised paradigm requires a large volume of label data, which we need to tackle. So to this end, our solution is that we propose a novel framework for the PQA task using heterogeneous information via a weak supervision paradigm, abbreviated as HIWS. So given a product-related question, our model exploits the corresponding product details and user reviews. So firstly, a heterogeneous information encoding component is developed to encode different information formats into a unified representation. Secondly, to handle the shortage of label data, we develop a weak supervision paradigm, making use of the original user-posted answers available during the training step. So here gives a more formal problem setting. For product P, its associated information can be represented as a tuple CP. So here, A is a set of attribute value pairs extracted from the corresponding specification table, and D denotes the textual product descriptions, and R is the review set. Now, given a question Q regarding this product P, our task is to automatically rank the candidate slippage in CP, which can either be a textual sentence from D or R, or an attribute value pair from A, for providing responses. So here is the overview of our model, which mainly consists of three parts: the heterogeneous information encoding, the question snippet relevance matching, and the automatic label construction to construct labels for supervising the training process. So firstly, the heterogeneous information encoding aims to encode both the candidate snippets, including natural language sentence and attribute pairs, to a unified representation, denoted as C. So C includes both CT and CA. Well, CT is a free text and CA is a set of aspects highlighting the most important information of this candidate snippet. So for natural sentence input, we use an existing aspect extraction algorithm to extract a set of aspect terms as a CA and just treat the raw text C bar as the CT part. And for an attribute value pair, since the most silent information is already highlighted in AI. So we directly treat AI as CA, and construct a pseudo sentence CT by concatenating the attribute and value terms. And in the second part, we measure the question snippet relevance both from their aspect enhanced representation and intent matching. So where we aim to measure which information source is better for answering the given question. Thirdly, in the automatic label construction, we take advantage of the original user posted answers to the question during the training process. So we construct, we consider the supervision from two perspectives. One is the syntactic relevance, motivated by using the root score to compute the relevance score. And the second is the semantic relevance, where we use some pre-trained text embedding method to measure the relevance. And to combine these weak supervision paradigms, so here actually we use different types of text embedding method. So we have S1, S2, and up to S4. So we have those different weak supervision signals, and we want to combine them into a single label Y for supervising the training process. So to combine them, we use a small amount of human annotated question snippet pairs to train a simple classifier for learning to combine them. So note that here we use the information from the original answer, so we can easily use a simple. So using a simple classifier can lead us to a high performance to construct a single label. But during the inference step, we do not have the information from the answer. We only have Q, and we need to measure its relevance with the candidate snippet. So which is different here from here. Okay, next I'll describe the experiment. So our dataset is constructed based on the Amazon QA dataset and the Amazon review dataset. The product details are called from the corresponding product pages. And here gives the summary statistics of this dataset. And for baselines, we use two types of baseline. One is the unsupervised, and the second is some supervised QA models. So for those supervised QA models, they take the question and the lateral sentence part of the candidate snippet as input, and they are also trained using the same automatically constructed labels as our proposed framework for more fair comparison. So this gives the main result for the response selection response selection task. So we can see that our proposed model achieves the best performance among all evaluation metrics. And some other observation is that some simple QA models can still achieve reasonable performance, but for those more advanced models, although they are equipped with complex network architecture, they do not perform as promising as expected. And this experiment shows the effectiveness of our weak supervision paradigm. So we investigate two alternative strategies for tackling the shortage of label data. One is with QA, denotes training with the QA pairs instead of the question snippet pairs. And with SQS refers to the model, which are first trained with QA, and then the small amount of annotated question snippet pairs are used to fine-tune the model. And with WS, it's just our proposed approach. And from the result, we can see that the model trained with the original QA pairs perform quite worse, which shows the semantic gap between the original answer and the candidate snippet. So we cannot just directly train the model on the QA pairs and use it to retrieve relevant information. And models with SQS outperformed the model with QA while fine-tuning, but still not achieve satisfactory results due to the limited amount of label data. And the performance for all models. So we also test the weak supervision paradigm on two models, the BIMPM and HCN. So all models can be the performance for for all models can be improved with the proposed weak supervision paradigm, so showing its effectiveness. So finally, is the conclusion part. So we explore to utilize the heterogeneous information, including attribute value pairs and natural language sentences from both product details and user reviews to tackle the PQA task. And to handle the lack of label data, we design an effective weak supervision paradigm, making use of the available answers in the training phase. And the experiments on real-world datasets shows the effectiveness of our proposed method. So that's all for my presentation. Thank you for your attention.